Have you ever looked at the ruins of an ancient civilization and thought, how did they do this? Massive stones cut with surgical precision, concrete that lasts thousands of years, machines that shouldn't exist until centuries later. Today, modern scientists and engineers spend billions trying to solve problems that the ancients seemed to answer effortlessly. But here's the mystery. Many of their techniques have been lost to time. We don't fully understand how they built them, why they worked so well, or even who first discovered the knowledge. In this journey, we're going to explore the great mysteries of ancient engineering that modern science still can't fully explain. Roman concrete that grows stronger with age, a 2,000-year-old Greek computer that should not exist, mountain roads carved by the Inca without wheels or iron, and stones so perfectly cut that they defy earthquakes even today. And the question at the heart of it all is simple. Did the ancients know more than we think? Stay with me, because by the end of this video, you may never look at history the same way again.
When we think of Rome, we imagine grand monuments, the Colosseum, the aqueducts stretching across valleys, the massive domes of temples like the Pantheon. But behind all of this glory was a single invention, something humble, gray, and ordinary to our eyes: concrete. Our modern world runs on concrete. Bridges, tunnels, dams, skyscrapers. It is the backbone of civilization. Yet here is the strange paradox. Modern concrete, for all our technology, is weak compared to the Romans. Within just 50 or 100 years, cracks spread, steel reinforcements rust, and entire structures have to be demolished or rebuilt. Every time you see a crumbling highway or a bridge in need of repair, that is the cost of modern concrete. Now, let's cross back 2,000 years. The Romans built harbors directly into the sea, exposed to waves, storms, and salt water. By all logic, these should have collapsed long ago. Yet the remains of harbors at Cosa and Baiae still stand, their foundations intact after millennia underwater. The Colosseum, battered by earthquakes, fire, and centuries of neglect, is still there. And the Pantheon in Rome, with its enormous dome made from unreinforced concrete, has survived for nearly 2,000 years, with no modern steel to hold it together. So, how did they do it? The secret lies in their recipe. Roman concrete, or opus caementicum, wasn't made like ours. While we use Portland cement, sand, and gravel, the Romans used a mixture of volcanic ash, lime, and seawater. On the surface, it seems simple, but inside this mix, something extraordinary happens. When seawater seeps into Roman concrete, instead of weakening it, as it would with ours, it triggers a chemical reaction. Crystals of rare minerals such as aluminum tobermorite and stridlingite begin to grow inside the cracks. Imagine that, a material that heals itself, slowly filling in gaps and becoming stronger the older it gets. In other words, Roman concrete doesn't decay, it evolves. Now, here's where it gets even stranger. The Romans seem to know exactly which volcanic ash to use. Ash from Pozzuoli, near Naples, became famous throughout the empire. Roman engineers transported it across the Mediterranean because it produced the most durable mix. This wasn't trial and error, it was knowledge passed down, perfected through generations of builders. One of the earliest writers to describe this was Vitruvius, a Roman architect from the 1st century BC. In his treatise, De Architectura, he wrote about the extraordinary strength of volcanic ash from certain regions, particularly when mixed with lime. He noted how it could harden even underwater, something modern builders still struggle to achieve. Fast forward to today. Teams of scientists have taken samples of Roman concrete from ancient harbors and placed them under electron microscopes. They've watched as these tiny crystals form naturally, locking the material together. Researchers from MIT and other universities have published papers trying to replicate the formula. They've even managed to create experimental Roman-style concrete that shows promise. But here's the truth: we still can't fully copy it. Every attempt has shortcomings. The balance of ingredients, the heat of the mixing, the exact ash composition, it all matters. And those details, the craft of Roman builders, have been lost. No surviving text gives us the full recipe. It's like having the ingredients for a legendary dish, but missing the chef's secret technique. Now think about what this means for us today. Every year, billions are spent repairing failing infrastructure. Bridges collapse, highways crumble, and entire cities need constant maintenance. In 2018, the Morandi Bridge in Genoa, Italy, collapsed, killing dozens, a tragic reminder of concrete's weakness. Imagine if we had a material like the Romans, a bridge that not only lasted centuries, but became stronger with time. The savings, the safety, the sheer durability, it would transform our modern world. And yet, 2,000 years ago, Roman engineers already had it. So the question remains, did they stumble upon this miracle material by chance? Or did they understand a chemistry far more advanced than we give them credit for? Were they master scientists disguised as builders, or practical engineers who simply refined what nature gave them? Whatever the truth, one fact is undeniable. The ruins of Rome stand as silent witnesses to a forgotten knowledge, one that modern science is still trying and failing to reclaim.
In the year 1901, a group of sponge divers exploring the waters near the tiny Greek island of Antikythera made a discovery that would puzzle the world for more than a century. From the depths of an ancient shipwreck, they pulled up bronze statues, jewelry, pottery, and one strange corroded lump of metal. At first glance, it looked like nothing more than rusted scrap, but inside, hidden by centuries of incrustation, was something extraordinary. When scientists carefully examined it, they found gears, dozens of them, perfectly cut, intricately designed, interlocking in ways that no one expected from the ancient world. This was the Antikythera mechanism, often called the world's first computer. Now, let's pause for a second. When we think of ancient Greece, we imagine philosophers like Plato and Aristotle, mathematicians like Euclid, or the builders of marble temples. But a mechanical computer made of precision gears for more than 2,000 years ago? That seems impossible. And yet, that's exactly what it was. The Antikythera mechanism could track the movements of the sun, the moon, and even predict eclipses. It could chart the positions of planets known at the time. It displayed complex cycles, like the Metonic cycle of 19 years and the Saros cycle of eclipses lasting 18 years, 11 days. With a series of dials and rotating hands, it essentially compressed the cosmos into a handheld machine. Modern X-ray scans of the fragments revealed at least 30 bronze gears, some with teeth less than a millimeter wide. To cut gears this precise requires not only knowledge of mathematics, but also advanced craftsmanship and bronze working. Even in medieval Europe, over 1,000 years later, gear systems of this sophistication barely existed. To find one in Greece in the 2nd century BC is nothing short of shocking. So who built it? Theories abound. Some scholars suggest it was designed by followers of Hipparchus, the Greek astronomer who developed a precise model of lunar motion.
Others point to Archimedes, the legendary inventor of Syracuse, who was known for his mechanical genius and may have created early prototypes. Whoever it was, their knowledge seems centuries ahead of their time. Here's the mystery. Why was there only one? If the Greeks had mastered gear-driven devices to this level, why don't we see dozens of them scattered across museums? Why wasn't this technology used to build mechanical clocks, navigation instruments, or other machines? Did it represent a lost branch of Greek engineering that disappeared with the fall of their civilization? Some historians believe exactly that the Antikythera mechanism is just the tip of an iceberg of ancient technology we've lost. The shipwreck may have been carrying other devices that never survived. Wars, invasions, and the decline of classical learning could have wiped out this knowledge, leaving only fragments for us to find. Others suggest the mechanism was unique, a one-of-a-kind masterpiece commissioned by a wealthy patron. Perhaps it was too expensive, too complex, too fragile to ever become widespread. And so, when its creators died, the knowledge died with them. But here's the fascinating part. The Antikythera mechanism doesn't just tell us about Greek science, it forces us to rethink our assumptions about history. We often imagine progress as a straight line. Primitive tools, advanced machines, modern computers. But history isn't so simple. Sometimes knowledge is gained, then forgotten, then rediscovered centuries later. Think about this. The first mechanical astronomical clocks in Europe appeared in the 14th century AD. That's more than 1,400 years after the Antikythera mechanism sank beneath the waves. In other words, humanity invented something once, lost it, and then had to reinvent it from scratch more than a millennium later. Even today, scientists are still debating exactly how the device worked. Every few years, new studies propose reconstructions, trying to imagine what the missing gears looked like. Some models suggest the mechanism displayed miniature planets moving across the front dial. Others think it was portable, like a scholar's tool, used for teaching or astrology. But here's the haunting question. If this one machine survived, how many others did not? What if ancient inventors created devices that could have transformed their world? Machines lost to time, buried in shipwrecks, melted down for bronze or destroyed in war. The Antikythera mechanism reminds us of something humbling. Human genius is not confined to the modern age. 2,000 years ago, with nothing but hand tools and bronze, someone looked up at the night sky and built a machine that captured the heavens. And that leaves us wondering, what else did the ancient world know that we've forgotten?
High in the Andes, winding through snow-capped peaks, plunging into deep valleys, and stretching across deserts, lies one of the greatest engineering achievements of the ancient world, the Inca road system. It's called the Capacnyan, the Royal Road. At its peak, it connected an empire that stretched over 40,000 kilometers, from modern-day Colombia all the way down to Chile. To put that in perspective, the Inca built more miles of roads through mountains, forests, and deserts than the Roman Empire did across Europe. And here's the truly astonishing part. They did it without the wheel, without iron tools, and without draft animals like horses or oxen. Imagine building a highway across the Himalayas using only stone tools and human labor. That was the challenge the Inca faced. And yet somehow they succeeded. The roads were more than just paths. They were lifelines of the empire. Some were simple dirt tracks, but many were paved with carefully fitted stone. In the highlands, steps were carved directly into mountain sides. Suspension bridges made of woven grass ropes spanned rivers hundreds of feet wide. These bridges had to be rebuilt every year,
yet they were strong enough to support armies of men. Spanish conquistadors who first crossed them were stunned. Some even refused to step onto the swaying structures, fearing they would fall. The Incas, however, walked them daily, carrying loads and messages with ease. Speaking of messages, the Inca didn't have writing as we know it. Instead, they relied on runners called chasquis. These trained athletes sprinted along the roads, passing messages and small goods from one station to the next. Like a human relay race, this system allowed information to travel astonishingly fast. Historians estimate that a message could move more than 240 kilometers in a single day, rivaling the speed of mounted couriers in medieval Europe. But how did they build such roads in the first place? The Andes are not gentle hills, they are brutal mountains with sheer cliffs, glaciers, and unpredictable weather. The Inca cut through rock, built retaining walls, and designed drainage systems to withstand heavy rains. In deserts like the Atacama, where there is almost no water, they marked routes with stone piles so travelers would not lose their way in the vast emptiness. And here's the mystery. The precision and durability of some of these constructions remain hard to explain. Retaining walls built without mortar still stand perfectly aligned after centuries of earthquakes. Steps carved into granite are so smooth and regular that modern stonemasons marvel at the skill. Even today, hikers on preserved sections of the Inca Trail walk along paths that feel astonishingly intact, almost as if they were laid just decades ago, not half a millennium earlier. When the Spanish arrived in the 16th century, they were both amazed and terrified. They had never seen roads like these in such impossible landscapes. The conquistadors quickly realized that controlling the roads meant controlling the empire. And indeed, by seizing key routes, they managed to dismantle Inca power. But even as they destroyed much of the civilization, the roads endured, a skeleton of stone across the Andes. Now, let's consider this. The Inca built all of this without the wheel. Yes, they knew about the wheel. Children's toys with small wheels have been found, but they never applied it to transport. Why? The terrain itself made it nearly useless. Steep mountains, narrow paths, and suspension bridges were not suitable for carts or wagons. Instead, the Inca adapted to their world, relying on llamas for carrying loads and their own ingenuity to move supplies and people. It makes us ask, was their choice not a limitation, but a kind of brilliance? Instead of forcing the land to bend to their tools, they built tools suited perfectly for their land. Today, archaeologists are still uncovering forgotten branches of the road system, buried under jungle or hidden in remote valleys. Some modern highways in Peru, Ecuador, and Bolivia follow Inca routes almost exactly, because no better path has ever been found. Think about that. In an age of GPS and satellite imaging, we are still walking the footsteps of Inca engineers. The Capac Neon wasn't just a road network, it was the backbone of an empire, a testament to what human determination and engineering can achieve against impossible odds. And yet, questions linger. How did they achieve such precision without metal tools? How did they coordinate construction across thousands of kilometers in some of the harshest terrain on Earth? and how much knowledge was lost when the Spanish conquest silenced their builders. The Inca roads remain both a triumph and a mystery, proof that great engineering doesn't always require advanced technology, but vision, organization, and a deep understanding of the land itself.
We've now seen three very different examples: Roman concrete that heals itself, a Greek machine that mapped the heavens, and a road network carved across the most brutal mountains on Earth. Each case leaves us with the same unsettling thought: how did they do it? It's easy for us, in the 21st century, to assume that we are the pinnacle of human progress. We fly across continents. We build skyscrapers that scrape the sky. We carry supercomputers in our pockets. Surely, we think ancient people were primitive compared to us. But the more we study their achievements, the more cracks appear in that story. Let's step back for a moment. The Romans had no steel beams, no bulldozers, no computer modeling software, yet their concrete structures still stand while ours collapse in a few decades. The Greeks had no electricity, no machine tools, no precision lathes, yet they built a device that functions like a clockwork computer. The Inca had no wheel for transport, no written alphabet, and no horses, yet their road system rivaled and in some ways exceeded the famous roads of Rome. It forces us to ask, are we truly as advanced as we think, or have we forgotten lessons that the ancients once knew? Modern engineers sometimes talk about lost knowledge. For example, we know from historical records that medieval swordsmiths once made a type of steel called Damascus steel, blades so sharp and durable they became legendary. And yet the precise method of making it was lost for centuries. Only in recent decades has scientists started to understand the nanostructures that gave Damascus steel its properties. This is not unique. History shows again and again that technology can be forgotten. Libraries burn, wars destroy knowledge, generations fail to pass down secrets. Progress is not a straight line, it is a fragile chain, and when one link breaks, entire worlds of knowledge vanish. Now, apply that idea to the ancient world. What if Roman engineers carefully guarded the secrets of their volcanic concrete, and when the empire fell, the knowledge scattered? What if Greek mechanical devices were rare treasures, each destroyed in war or melted down for bronze? What if the Inca road-building techniques were transmitted orally, only to disappear when their culture was shattered by conquest? This perspective shifts how we see history. Instead of imagining the past as a steady march forward, we might picture it as a jagged mountain range, peaks of brilliance rising out of valleys of forgotten knowledge. Some peaks survive in ruins and artifacts, others are lost entirely. And here's another puzzle. How much of what the ancients built came not just from trial and error, but from an understanding of natural forces that we've underestimated? Roman concrete, for example, wasn't just luck. The specific ash they chose created chemical reactions that modern chemistry has only recently begun to explain. The Antikythera mechanism wasn't just tinkering. It required mathematical models of planetary motion so advanced that they rivaled what Renaissance astronomers knew. The Inca roads weren't just persistence, they reveal a mastery of terrain, climate, and logistics that modern military planners still respect. Perhaps the real mystery is not whether the ancients had magical knowledge, but whether we have grown arrogant, blind to the intelligence of those who came before us. Consider this. 2,000 years from now, if our digital records were destroyed, how much of our knowledge would survive? Microchips would corrode, servers would fail, satellites would fall silent. A future archaeologist might dig up the ruins of a collapsed bridge and wonder, why couldn't these people make concrete that lasted? The truth is, we are only temporary custodians of knowledge. If we fail to preserve it, we too could become another mystery in the long story of human history. And that is why studying ancient engineering matters, not just because it's fascinating, not just because it's mysterious, but because it reminds us that human ingenuity is timeless. The same spark of creativity that built the Pantheon, the Antikythera mechanism, and the Kapak Neon is the same spark that drives us today. The question is, will we learn from the ancients or forget their lessons once again?
On the coast of Egypt, more than 2,000 years ago, stood a structure so tall, so brilliant, and so advanced that it became one of the 7 wonders of the ancient world. It was called the Pharos of Alexandria, the Great Lighthouse. Built in the 3rd century BC under the rule of Ptolemy II, it rose between 100 and 130 meters high, nearly the height of a modern 40-story building. For centuries, it was one of the tallest man-made structures on Earth, second only to the Great Pyramid of Giza. Mariners could see its shining beacon from more than 50 kilometers away, guiding ships safely into the busiest harbor of the Mediterranean. But here's the mystery. How exactly did it work? Ancient accounts describe a brilliant light shining from its summit. Some sources claim it was produced by a massive open flame amplified by polished bronze mirrors. Others describe the use of a mysterious burning glass, a device that could focus sunlight into a powerful beam, centuries before modern lenses were perfected. There are even legends that the pharaohs could set enemy ships on fire by directing its light, though historians debate whether this was exaggeration or truth. Regardless of the exact mechanism, the lighthouse was more than a simple flame on a tower. Its construction required extraordinary engineering. The base was square, supporting a middle section that was octagonal, topped by a circular tower and a statue, possibly of Zeus or Poseidon, watching over the sea. This layered design helped stabilize the massive structure against earthquakes, though eventually tremors in the 14th century would topple it into ruin. Let's pause to consider the scale. In an age with no cranes, no steel reinforcement, and no modern concrete, workers moved thousands of tons of stone, some blocks weighing over 20 tons each. They built walls several meters thick to withstand the sea and wind. The logistics alone, transporting stone across the Nile Delta, organizing labor, feeding workers, were a triumph of planning and execution. And yet, the Pharos wasn't just a building. It was also a symbol of knowledge and power. Alexandria was the intellectual capital of the ancient world, home to the Great Library. The Pharos was its shining counterpart, a technological marvel that proclaimed to sailors, merchants, and scholars alike that Egypt was a center of science and innovation. But here's where the questions begin. How exactly did ancient engineers polish and shape bronze mirrors large enough to direct light across such distances? Our modern understanding of optics didn't fully emerge until many centuries later, with scientists like Alhazen in the Islamic Golden Age and later Galileo. Could the Ptolemaic engineers really have mastered reflective technology so advanced? Some archaeologists believe the mirror was not a single giant reflector, but a system of angled polished metal plates, bouncing light upward from the flame toward the sea. Others argue that the ancient descriptions may have been exaggerated, that the lighthouse's brilliance came more from the sheer size of the fire than from any optical trickery. Still, the very idea that people even imagined giant mirrors focusing beams of light in the 3rd century BC speaks volumes about their ambition and vision. Even in ruins, the influence of the pharaohs lived on. For centuries, it was the model for lighthouses across the Mediterranean and beyond. The very word pharos became synonymous with lighthouse in many languages. In French, phare. In Italian, faro. In Spanish, faro. Its legacy survived long after the stones themselves had crumbled into the sea. Today, divers off the coast of Alexandria can still see massive blocks from the lighthouse lying beneath the waves. Some archaeologists dream of reconstructing it, combining history with modern engineering. But perhaps more important than rebuilding it physically is to understand what it represented, the blending of practicality and mystery, of science and imagination. Think about it. To an ancient sailor approaching Alexandria at night, the pharaohs must have looked almost magical, a star on earth guiding them to safety. To us, it is both an engineering puzzle and a reminder of what humans can achieve with vision and determination. And just like Roman concrete, the Antikythera mechanism, and the Inca roads, the pharaohs of Alexandria leaves us with unanswered questions, not just about how it was built, but about the minds that dared to conceive it.
We've journeyed across empires, Rome, Greece, the Andes, and Egypt, and in each case we've seen something that challenges our assumptions. Concrete that heals itself, a machine that maps the cosmos, roads that cut through mountains without wheels, a lighthouse that seemed to bend light itself. What ties these stories together? One word: loss. Think about it. The Roman recipe for concrete is gone. We have fragments, scientific clues, but not the exact method. The Antikythera mechanism lies in pieces, and whatever workshop produced it has long vanished. The Inca road system still stretches across the Andes, but the knowledge of its builders, the exact techniques they used, disappeared with the empire. The pharaohs collapsed into the sea, leaving us only rubble and legends. These aren't just stories about engineering. They are warnings. Knowledge, once lost, is incredibly hard to recover. Entire civilizations can vanish, leaving behind monuments we struggle to understand. What we call progress may not be as linear as we believe. History may be less like a straight line and more like a wave, rising, crashing, and rising again. Consider how fragile our own world of knowledge really is. Today, we live in a digital age. Billions of documents, books, and records exist only on hard drives and servers. If those servers fail, if data is corrupted, if power grids collapse, how much would survive? A Roman aqueduct can still carry water after 2,000 years, but how many of our digital files will last even 50? It raises a haunting question. How many times has humanity already started over? Could there have been more Antikythera-like devices that rusted away, more pharaoh structures that crumbled, more secrets of chemistry and metallurgy that disappeared? What if the peaks of human genius rise more often than we realize, only to fall into shadow before being rediscovered? There is a phrase some historians use: civilizations are built on forgotten knowledge. In other words, every generation inherits fragments of brilliance from the past without always knowing where they came from. Roman arches inspired medieval cathedrals. Greek geometry laid the groundwork for modern science. Inca stonework still informs earthquake-resistant design. Even in the ruins, the ancients continue to teach us. But here's the part that should make us pause. If so much has already been lost, what are we losing right now? Languages disappearing, traditions fading, knowledge reduced to data on fragile devices. Future generations may look at us the way we look at the Romans and the Greeks, as brilliant, yes, but also careless, blind to what we allowed to slip away.
And yet, there's also hope. The ruins of the past remind us not just of what was lost, but of what is possible. They show us that human creativity is timeless, that 2,000 years ago, without electricity, without steel, without satellites, our ancestors still solved problems that baffle us today. That means ingenuity is not tied to technology. It is tied to imagination. So perhaps the real lesson of these ancient enigmas is this: progress is not guaranteed, but as long as we continue to ask questions, to preserve knowledge, and to learn from those who came before us, we can keep the chain unbroken. Because the greatest tragedy is not that we don't understand the Roman concrete, or that we can't fully reconstruct the Antikythera mechanism. The greatest tragedy would be if we stopped wondering, stopped searching, and stopped learning from the mysteries of history.
As we close this journey, one question lingers. Why do the mysteries of ancient engineering matter today? It's tempting to see them as curiosities, puzzles from long ago, entertaining but irrelevant. Yet when we look deeper, they tell us something profound about ourselves. They remind us that human beings are capable of greatness long before the modern age. They remind us that progress is not inevitable, that entire worlds of knowledge can vanish if we don't protect them. And they remind us that what survives, what echoes across time, is not the empire, not the wealth, not the politics, but the ingenuity, the imagination, the spark of creation. Think of Roman concrete, forgotten for centuries, and yet today its secret may help us build sustainable cities. Think of the Antikythera mechanism, rusted and broken, yet still pushing modern engineers to rethink what's possible. Think of the Inca roads, silent pathways across mountains, still teaching us resilience and endurance. Think of the lighthouse of Alexandria, gone for over 1,000 years, yet still inspiring visions of how humans can command light and sea. These are not just ruins, they're conversations across millennia. The ancients are speaking to us if we are willing to listen. And so, the real challenge is not simply to uncover their secrets, but to honor them, to take the lessons hidden in stone, bronze, and concrete and carry them forward, to ensure that we too do not become a lost civilization, remembered only through fragments and ruins. Because the truth is sobering. One day, we will be ancient history. Future generations may look back at our skyscrapers the way we look at the pyramids. They may wonder how we built them, or why we allowed so much knowledge to disappear. The question is, what will we leave behind? Will it be fragility, lost data, vanished languages, knowledge locked away in forgotten formats? Or will it be strength, ideas, wisdom, and structures that endure through time, the way Roman aqueducts still endure? That choice is ours. And perhaps that's the greatest gift of these mysteries. They don't just show us the brilliance of the past, they challenge us to think about the legacy we are creating right now. So, the next time you walk past an old building or hear about an artifact discovered in the earth, don't just see it as history. See it as a reminder knowledge is fragile, progress is fragile, but imagination is eternal. Androtic tone, stay with us, because this journey has only just begun. There are still more secrets waiting, vanished cities, impossible maps, lost inventions that defy explanation. Each one is another doorway into the past, and perhaps into our future. So,
Subscribe, share this story, and join me again as we uncover more mysteries that modern science still cannot explain. Until then, remember, the ruins are never silent. They are speaking. We just have to listen.